In the last session, we calculated maximum utility given the utility function. In this session, we're going to work out maximum utility given a table. Let us look at this example. A boy pockets money is 10 rand and he buys lunch of pizza at 2 rand and cola at 1 rand. And we are told that pizza is on the x-axis and cola on the y-axis. Let us show that on a graph. So this is the y-axis and this is the x-axis, and we are told that cola is on the y-axis. So this is cola here, and a slice of pizza, it's on the x-axis. And we are given a budget line. So the budget line will go like this, straight like that, and we are looking for maximum utility on an indifference curve, right? So what we are given when it comes to this example, we know that a slice of pizza equals to 2 rand equals to x, and cola equals to 1 rand equals to y, and the income is 10 rand. When we look at this table here, this table shows the total utility derived from consuming quantities 1 to 5 of either a slice of pizza or cola. So the first thing that we do is that we need to determine the budget line. And we know that the equation for the budget line is I equals to price, that is income equals to the price of x times quantity of x plus price of y times quantity of y. In this example, we know that the boy's budget is 10 rand, that is his income, and the price of x is 2 rand, that's the price of pizza, and of y, it's 1 rand. So what do we get? The budget line is defined as 10 equals to 2x plus 1y. The second step is to find the marginal utility of x and marginal utility of y. We know that marginal utility is change in total utility divided by change in Q. When we will start, let's first start with pizza. So we can see here that at 20, that is our initial utility, so there is no change. So marginal utility of consuming 1 slice of pizza is 20. What about marginal utility of consuming 2 slices of pizza? We can see total utility is 36, so a change in total utility is 36 subtract 20 divide by 2 subtract 1, right? That is change in total utility and change in quantity, and that gives us 10. That gives us 16, right? And what about when the boy consumes 3 slices of pizza? That is, then we get 46 subtract, so we get 46 subtract 36 divide by 3 subtract 2. So 46 less 36 is 10. 10 divided by 1, it's 10. At 4 slices, it's 52 minus 46, and that gives us 6. Marginal utility of 6. At 5 slices, it's 54 less 52, and that gives us marginal utility of 2. Let us calculate that of the cola. We can see that when it comes to quantity, the change is 1. Because it's 2 subtract 1, 3 subtract 2, and it's just 1. So our marginal utility is 35. When it's 1 cup or 1 glass of cola, marginal utility is at 20. At 2 colors, it's 35 less 20, and that gives us 15. At 3 colors, it's 45 less 35, that gives us 10. At 50 less 45, it gives us 5 and 3 when the boy consumes 5 colors. So now we found our marginal utility of X and our marginal utility of Y. But we know that our equation for maximizing marginal utility is MUX divided by MUY equals to PX over PY. And this can be rewritten as MUX divided by PX equals to MUY divided by PY. So the next step, we are looking for MUX divided by PX. Remember, the price of X is 2. So this is an easy one because we already know what our MUX is. We have calculated it and it's on this column here. So MUX and our price is 2. So 20 divided by 2 is 10. 16 divided by 2 it's 8. 10 divided by 2 is 5. 6 divided by 2 is 3. 2 divided by 2 is 1. We do the same thing when it comes to the collar. We know that the price for the collar, it's 1 rand, and our MUY is already calculated. So it's MUY divided by PY. It's 20 divided by 1. So this one is easy. 20, 15, 10, 5, and 3. And we said marginal utility is maximized when MUX over PX equals to MUY over PY. So let us see where MUX over PX equals to MUY over PY. So we can see that at quantity 1, MUX is 10. And when we come to the collar side, MUY PY 10 is when the boy consumes 3 collars. So we can see that at 1 pizza, MUX is equals to MUY when quantity of collar is at 3. What about MUX at 8? Nothing equals to it on this side, but we can see that at 3 slices of pizza, MUX over PX is 5, and at 4 collars, we get MUY over PY at 5. And we get the same thing at 4 slices of pizza at 3, and at 5 collars, we get 3. So we have 3 possibilities where utility can be maximized. Let us go back now to the budget line and plot in the quantities into our budget line to see if the boy can maximize utility given his budget. And we know that the budget is 10 equals to 10x plus 1y. So let us first check at MU divided by price equals to 10. At MU divided by price equals to 10, we can see that it is 1 slice of pizza and 3 collars. So we plot that into our budget line, and we can see then that it becomes 2 times 1 slice of pizza plus 1 times 3 collars, and that gives us 5. But that 10 is greater than 5. So 5 is less than our budget. So the boy is not maximizing his utility here. What about at MU divided by price equals to 5? So at MU divide by price equals to 5, we have 3 slices of pizza, and 4 collars. So that gives us, when we substitute it into our equation, it's 10 equals to 10. It looks like our boy maximizes his utility here when MU divide by price equals to 5. But let us continue, because we also have the third option. Let us see at 3 what happens there. So we can see that when we substitute, because at 3 we can see it's 4 slices of pizza and 5 collars, and this gives us 13, which is greater than 10. So we can then conclude that the boy maximizes his utility when he consumes 3 slices of pizza and 4 collars. So I need you now for your homework and to just put it in the comment section. If you can find then, if you can calculate total utility where the boy maximizes his utility. Please remember to like, to subscribe, and to comment. Thank you.